Section 3.4, the 5-number summary and box plots. We are going to introduce those 5-number summary and how we calculate them, and then how we use those to construct the box plot. So to start with this, I'm going to start it as an example. So I'm going to start this as an example. Let's say we have this data given by as 3, 4, 7, 9, 10, 13, 14. And as you notice, the first thing, the data is arranged in ascending order. If it's not given in ascending order, we must arrange it in ascending order first, from smallest to largest. Now, when we look at this data, we're going to find the median for this data, which is the middle number. This is the median. That's the median for the whole data. Now, this median split the data in half. We call it lower data and upper data. Lower data and upper data. So this is the lower data, this is the upper data. The lower data has a mean. Has a median. So the median for the lower data is 4, right? So that's the median for lower data. This is called Q1. Okay. And why we call Q1 is called first quartile. Is the median for the lower data. And 13 is the median for the upper data. Now the middle one here, the 9, is called Q2, second quartile. And this one is Q3, third quartile. Is the median for the upper data. So here we got Q1 to be 4, we got Q2 to be 9, and Q3 to be 13. Now the minimum value, the point that we have is 3, and the maximum is 14. Those are what we call the 5-number summary. The 5-number summary. So we always first, again, arrange data in ascending order. Take the median for the entire data, that's Q2 all the time. Then the lower data has a median called first quartile, and the second half of the data, upper half of the data, has also median called third quartile, Q3. Now, we have another thing to introduce here. These quartiles, the way it works is that if we plot this on the graph here, let's say that's a 3, 4, 5. We include all the numbers regardless if we're going to use them or not. So that's the lowest part of the data. That's the lowest one, the minimum, and this is the maximum. See, we put dots at these ones, and then 4 was the lower quartile or first quartile, and 13 was the upper quartile, and 9 was in the middle. We put these vertical bars. If you connect them this way, that gives you the box plot, and connect this to the lowest to the highest. The whole thing some people call box and whisker plot, or box plot. So this is important here to see. And what else we can learn about this one is that so the first quartile represents this quartile here represents the 25th percentile, we say. So this means like 25% of the data falls below that. The middle one is the 50th percentile. Why we call it median? Because it's in the middle, it's 50%, and this would be 75th percentile. You will learn more about percentiles later on. Now, if I take the Q3 here and subtract Q1, I got something called inner quartile range. Inner quartile range, abbreviated as IQR. And what is IQR? It's the measure of the spread. It tells you like how long this box is, right? It tells you how long this box is. So we can say that the IQR is a variation, defined as a variation. And what does it do? It measures the range. It measures the range of the middle 50% of all observations. That's what this does. That's what IQR is. So now we have two things talk about the variation or the spread, the spread of the data. We have two things. One is the one we introduced in the previous section is the standard deviation. And the other one is this one, the IQR. Now, when we are using the standard deviation, it is preferred to use the mean. We use the mean as a measure of center. I'll show example about this. And the other one is the IQR. In this case, we use the median. We use the median as a measure of center. Okay, so this is these two talk about variations or talk about the spread, and that's what each one is. We learned in the previous section how to find the standard deviation, and in this section we learned how to find the IQR. Let me take another example about finding the let me write it here. Another example about finding, so find the 5-number summary. For the data 98, 90, 70, 18, 92, 92, 55, 83, 45, 95, 88, 76. So the first thing is, which is important, is to arrange the data in ascending order. So I see the lowest value is 18, then 45, then 70. No, actually we have 55. We missed the 55. You see the 55. Then 70. Then 76, 83, 88, 90, 92, 2 times, so 88, 92, 90, then 95, and the last one 98. We arrange them. Now, how many data sets are there? We count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's even number of them. So to find Q2 first, or the middle one, we have to average the middle ones. So we have 12. We go 1, 2, 3, 4, 5. That's 5 here. 1, 2, 3, 4, 5. That's another 5. So these are the middle ones. So to find Q2, we average 83 and 88 divided by 2. That gives me 85.5. That's the median for the entire data. That's the median for the entire data. Now we can find, look at the lower data, the underlined part here, and notice what do we have for Q1. So the lower data, so notice this is important to know. The 85.5 goes somewhere here. So the lower data is not just the ones that I underlined, but the whole thing all the way up to 83. So 83 is included with the lower data. Where's the median? Well, there's no middle value. That's why we do the same thing. We look at the middle values, these two, and average them. That gives me Q1. Q1 is 55 plus 70 divided by 2, which is 62.5. So this is first quartile. And for the upper data from 88 on, That's Q3. Q3 is, we take the middle ones, 92 and 92. That gives us 92. That's the third quartile. The minimum is 18, maximum 98. And if in case we need to find the IQR, again it's Q3 minus Q1, 92 minus 85.5, 6.5. So that's the IQR, the inner quartile range, for the whole data. Now, I'm gonna take a look at another example. Let's say we have this. I'm gonna have it arranged already in ascending order. 50, 50, 53 times, 56, 60, 60, 75, and 250. So if you happen to find the mean, I calculated already and I got 76.2, and I found the standard deviation is about 62.3, and then I found the median of data is 56, and the IQR I found it to be 17.5. Let's talk about this information. Which one would be the best of measure of central tendency to use? Is it the mean or the median? And if I use the mean, should I do standard deviation or IQR? Which one goes with which? I told you earlier, always if you are using the standard deviation, we go with the mean. If we use IQR, we go with the median. And we're gonna try to see it here. How does that work? So let's say I'm gonna plot these, go by increment of 50. So this is 100, 150, 200, 250. So then I'm gonna plot these points here on the graph. So 35, estimated to be here. 50, another 50, another 50, 56, let's say here. 60, 60 again, 75, and 250. See 250 there. So these are the dots that we put in here. Now, if we look at the mean, where is the mean? The mean is 76.2. 76.2 is this is 75, so this was 75. So 70, it's somewhere here. That's where the mean is. That's not a good center for this data because it's more than most of the data in this set. It's more than most of those observations. So the mean is not a good center of measure of tendency in this case. But if we look at the median is 56. So let's say it's somewhere here. See, like it's much better this way. That's the median. It's much better for central tendency. So we say the mean is not a good center of measure for this data. For the above data. But the median is, right? Note, we use the median. The median is much better measure. Is much better measure of central tendency, and it's usually used for skewed data. Skewed data. So we figured out that the median here, because this is skewed, it's much better. And notice something here. The 250, we called it the outlier earlier. The 250 is, if we take 250 and make it like 500 or 600 or something, what happens? The mean, that will shift the mean to the right side. It will make the mean bigger and bigger. So the larger that you make that 250, the larger the mean. But the median is going to stay there. That's why for skewed data, because this data is skewed to the right, right? Like it goes like this. So the skewed data, median is much better to use than the mean, as you can see from the diagram. Now, what about the spread? So the spread, is it better to use standard deviation or IQR? Well, the standard deviation tells you how far are you above or below the mean. Above or below the mean. Notice something, if we find, if you look at the number 17.5, the IQR, or at least the standard deviation. The standard deviation, the spread is really big here because of the 250 that we have there, because of 250. So it tells you that 250, how far the 250 above, away from the mean. But the IQR, the 250 does not affect it. The IQR has nothing to do with the 250, because when we find the IQR for such a data, and which we did, it's the 17.5. Why is that? Because we found, if you look at data, you can find Q1 is 50 and Q3, the third quartile, is 67.5. From here we can get the IQR by subtracting them. 67.5 minus 50, and this is the 17.5. That's what IQR is. So that's why we say the IQR is much better used for spread than standard deviation, because no matter how big the 250 you make it, the IQR is going to stay the same. But if you make 250 500, for example, the standard deviation will get bigger and bigger. So that's why it's better to use IQR, and that's why IQR and the median go together. Standard deviation and the mean, they go together. Now, what can be a real life example here that we have? Let's say we talk about real life examples. It could be like home prices. I like the home prices the most. So sometimes in a community, let's say in Irvine, the average price, like you never hear someone saying the mean price of the houses. You say the average price of a house let's say 800,000. But what happens is this looks good for average price of the house. Now, if you try to use, so when I say average, we mean the mean. That's the average, right? The average is the mean. Now, when you try, or people say the average or the mean price of the house is this, but we always prefer here to say the median price of a house is 800,000. Now, which one is more appropriate to use? I tell you the median price. Why? Because if in case, like this is really the mean or the median price of the house. If in case you go to we have in Irvine, the Shady Canyon. So the houses are all in the millions, right? So what happens is you got maybe a house somewhere in this area or this community. It's not even 800, maybe it's like 3 million or 4 million. Then if the house price in that community 3 million, what that is going to do is going to shift the mean price of the houses. Is going to shift it up, but the median is going to stay the same, the median. So if that makes sense. So if you increase the price of a house, if someone decide to sell a house for, instead of like 900,000, they decide to put it for 2 million, it's not going to change the median price of the house, but it will change the mean. That's why we use the median price of a house, the median price of house. That's an example from real life situations. Now, Another thing I want to talk about in this section, here on the left side, notice how if you got exactly 25% of data falls in the below this, that's what the first quartile is. 25% of data falls in here, 25%, 25. That's called uniform distribution. That can be represented also if it comes like this, a bell shape, like symmetric figure. The figure will look like this. 25% will fall here, 25, 25, 25. But then if it's skewed to the right, the graph will look like this one, and skewed to the left will look like this one. Now, this is about quartiles, the one I mentioned earlier, and how you determine them. This is the IQR that we went over, and these are the 5-number summary that I just finished. Now, I need to talk the last thing about the lower and upper limits. We call them lower fence. This is called lower fence and upper fence. So what are these lower fence and upper fence? They help us to find, any outliers. So let's say you find the lower limit or lower fence here and upper fence here. Lower fence, upper fence. Any data in the shaded region is called an outlier. Any point that falls in there is called an outlier. So how do you find the lower fence? We take Q1 minus 1.5 times the IQR, and the upper limit or upper fence is Q3 plus 1.5 times the IQR. So for example, let's say we have this data 4, 5, 5, 7, 8, 11, 33, right? So first thing we need to find is Q2. Q2 is 7. Then this is Q1. Q1 is 5. This is Q3. Q3 is 11. Why did I find these? Because I need to find IQR. IQR would be Q3 minus Q1, which is 6. Then the lower fence is Q1 minus 1.5 times IQR. And what do we get for that? Q1 is 5 minus 1.5 times 6. Let's see what we get. 5 minus, this is 9, and that gives me a negative number, which is okay. That's the lower fence. The upper fence is Q3 plus 1.5 times IQR. And what we get for this, Q3 is 11 plus 1.5 times 6. So that's 11 plus 9 again. So that's 20. So now look at the given data. Any point below -4? No. From the blue line? No. Anything above 20? See, this is the upper fence. Yes, 33. Do you see? So 33, since the 33 is bigger than 20, we call 33 an outlier. Before, in the previous sections, we were kind of like guessing, comparing that data value to the entire data set or observations. We find, oh, I think this is an outlier. But here you have a computational method to confirm if the given number or numbers are outliers or not. So that's how we find the lower fence and upper fence, or lower limit and upper limit. And this is just a diagram to represent what I was talking about earlier. When you find them, what is Q1, what is Q2, Q3 on the graph, and then how that helps us to graph the box and whisker plot or the box plot. Now they are telling us here, if the graph is symmetric, like the middle one, then the two tails on both sides, call them the whiskers, this one and this one, they should look the same in lengthwise. If it's skewed to the right, left on the right side here, if it's skewed to the left, as you know, longer tail here, then we expect the longer tail here or the whisker here to be longer. Same thing there. If it's longer on this side, the box and whisker plot should be longer on the right side as well. That's what this section is all about.